Hello there, amazing people, students, subscribers, and all the lovers of chemistry out there. I'm super excited to be here with you on today's episode for question for the day. And the question we have to solve today is a question that combines two topics, the topic of stoichiometry and the topic of electrochemistry. So let's go into the details of what this question entails and solve it step by step. So the question starts off by saying during the electrolysis of copper 2 sulfate solution using copper electrodes, a current of 2 amperes is passed for 30 minutes. Calculate the mass of copper that is deposited at the cathode. And they've given us some information, some bits and pieces of information that I've been needing in the process of solving this question. The first thing they told us is the relative atomic mass of copper, which is 63.5 grams per mole. And then the next thing they told us is the Faraday's constant, which states that 96,500 coulombs are required to move 1 mole of electrons. And then they told us that 2 moles of electrons are required to deposit 1 mole of copper. So let's go ahead and solve this question step by step. So now, the first thing we need to understand is to know the formula we are to use to get the mass of copper that is deposited. Now, since this question combines stoichiometry and electrochemistry, remember that the mass of a substance M, mass is equal to the number of moles of that substance multiplied by the molar mass of the substance. So now some questions I want to ask is, we don't know what the mass of copper is because that's what they told us to find. And then we do not know the number of moles of copper that we have because they did not give it to us in the question. But we have the molar mass of copper, which is 63.5 grams. So in order to use this formula, we need to find the number of moles of copper. And in order to find the number of moles of copper that is used, we need to know some things. We need to know the charge that was used up in the chemical reaction, and we also need to know the number of moles of electrons. Number of moles of electrons that was used. So let's go ahead and calculate everything step by step. Now, from Faraday's first law of electrolysis, charge Q is equal to the amount of current in amperes, which is I, multiplied by T. Q equal to IT. Now, I stands for the current in amperes, which is 2, because you can see over here we have 2 amperes. And T stands for time in seconds, and we have 30 minutes. So we need to convert 30 minutes into seconds. To convert minutes to second, what you simply do is to multiply by 60. When we multiply 30 by 60, we end up having 1,800 seconds. So therefore, we can impute the variables into this formula to get the charge that was used in the chemical reaction. So now we have 2 multiplied by 1,800 seconds. This gives us 3,600 coulombs. Because charge in electrochemistry, Q, is measured in coulombs. So now that we have the charge, the next thing we want to find out is to find out the number of electron moles that were moved by this charge. And when we find the number of electron moles that was moved by the charge, then we can now go ahead to find out the number of moles of copper that was produced, and then find out the mass of copper. Let's take it step by step. Now, according to the question, we were told that 96,500 coulombs are required to move 1 mole of electron. 96,500 coulombs moves 1 mole of electron. So now, 3,600 coulombs will now move an unknown number of electrons. I'm sure you're following every step of what we're doing. So at this point, we can cross multiply. If we cross multiply, it now becomes 96,500 times x is equal to 3600. If we do a quick math, x will now be equal to 3600 divided by 96,500. So let's go ahead and punch our calculators and get what our answer will be. So 3600 divided by 96,500 gives us 0.0373. 0.0373 moles of electrons. So now that we have the number of moles of electrons that were moved by 3600 coulombs, the next thing we are going to find out is the number of moles of copper that was produced by this number of moles of electrons. I'm sure you're following every step of the way. Now, from the question, we were told that 2 moles of electrons are required to deposit 1 mole of copper. So we have 2 moles of electrons deposit 1 mole of copper. So therefore, 0.0373 moles of electrons will now deposit an unknown number of moles, x moles of copper. So at this point, we can also cross multiply. It now becomes 2 multiplied by x, 2 times x is equal to 0.0373. If we do a quick math, this divided by 2 will give us 0.0373 divided by 2 gives us 0.0187 moles of copper was produced. So now that we know the number of moles of copper that was produced, let's go ahead and use it to find the mass of copper that was produced, because the question says calculate the mass of copper deposited at the cathode. So let's go ahead and find out the mass of copper that was deposited at the cathode. Now we know that mass is equal to number of moles times the molar mass of a substance. Now we don't know what mass is because that's what we're looking for. Now, number of moles, we have calculated the number of moles of copper to be 0.0187 times the molar mass of copper now, which is over here, 63.5. So when we do this multiplication, 0.0187 multiplied by 63.5, what we end up having is 1.188 grams of copper produced. So we've gotten our final answer. Final answer to this question is the mass of copper deposited at the cathode is 1.188 grams. So in a question like this, the first thing we do is to calculate the charge, then use that information of the charge that was calculated to now get the number of electrons that were displaced by that charge, and then use the information of electrons that you have gotten to calculate the number of moles of that substance that was deposited. I hope you followed every step of this. If you enjoyed it, please like, share, and subscribe to my YouTube channel, and I'll see you in the next video.